Hi, we are in S domain now. What we have done, we have the first frame here I'm talking about. That frame. What's going to be the Kirchhoff current law and Kirchhoff voltage law equations in S domain? What's going to be the definition relation of the elements that we have seen in S domain is related with this frame. And then we have seen serial parallel connections in S domain, how we are using these connections in the analysis, how does this help us to solve some of the circuits, some specific circuits, serial parallel connected circuits. The other subject that we examined is the source transformation. Source transformation is another facility that we use in order to simplify the analysis in S domain. Now we will be examining this frame. This frame tells about something, general analysis techniques. These analysis techniques, why we call it general analysis techniques? Because in these techniques we will be finding out all the elements current and voltages, not part of it, just all the elements current and voltages. That's why we call it general techniques. There are three of them: classical method, node voltage method, mesh method. In here we will be examining the classical method. In this video we will be examining this classical method, and then later on we are going to examine natural and forced solution in S domain. These are the solutions that we couldn't calculate in frequency domain. Now in S domain we will be doing so. Specific analysis techniques, if we are dealing with only one of the element, which is output element, this element current and voltage, if we are dealing with only this output element current and voltage, then we use these special analysis techniques. This techniques includes Thevenin and Norton equivalent circuits. So let's come to this general techniques, this video subject now. Within this video we will be examining this classical method only. So this circuit, the specific circuit that we have chosen here, is the same as the one that we used in serial parallel connected circuit analysis and the source transformation. So we will be analyzing the same circuit for the classical method once more here. Then we would be able to compare those three methods. So let's move to open circuit now, but we've got to change it in OBS as well. Open board. Now we could go there. That's the circuit given in time domain. This is time domain circuit. So we transfer this time domain circuit to S domain here. That has been done already, so I'm not going to repeat it once more. So if you see here, this is our circuit. The classical method, in the classical method we are going to write two any equations. Two any equations mean any is the number of elements in this circuit, so the total number of elements is 5. So altogether we are going to write 10 equations. How we are going to find these 10 equations? We are going to write independent KCL equations, and there are ND minus one of them. ND is the number of nodes. If this node is chosen as a ground, so there are 1, 2, 3, 4, including the ground. So minus 1, so discard this node. So there are only 3 nodes in this circuit, and D minus 1 is equal to 3 then. So we are going to write 3 Kirchhoff current law equations. These are the independent equations. And then we are going to write independent once again KVL equations. These are NE minus ND plus 1 equation. NE is 5, ND is 4. So plus 1, so 2. There are 2 independent Kirchhoff voltage law equations that we are going to write. These equations are going to be the ones which are written for the meshes. So we've got 2 meshes. One of them is this. This is one mesh. So that's the other mesh. What is left is definition relation. How many of them? Each element must have a definition relation, so there are any definition relations. When you add those up, you're going to end up with 2NE. So the number of equations, independent equations, so these are all independent equations. Number of independent equations is 2NE, and the unknowns are also equal to NE. The number of unknowns is equal to NE. Again, why is that? Because any element, each element has got a current and voltage, so there are 2 NE unknowns. So number of equations equal to number of unknowns means you're going to write an algebraic equation in that form. So this is how we are going to write this algebraic equation. The solution of this algebraic equation is going to be rational functions for all elements, current and voltages. So let's write this KCL, Kirchhoff current law equations for the first node. That's the first node. There are 2 elements connected. According to passive sign convention, this current direction is downwards, isn't it? So the first node Kirchhoff current law equation, IS plus I1 is equal to 0. Both of them coming out of the node, therefore the sign of those 2 currents are equal to 0. And yes, the second node is this node. There are 3 elements connected to that, so we are going to write 3 currents in this equation. So this one is towards the node, so I'm writing this node equation, so this current is coming towards the node, minus I1. This coming out of the node, plus I20. And this inductor current is also coming out of the node, therefore it is IL with the sign plus is equal to 0. So this is Kirchhoff current law equation for this second node. So the last one is the third node. Third node, inductor current coming towards the node is minus IL. Capacitor current is coming out of the node, so plus IC is equal to 0. These are all currents in S domain. That's why these are capital letters written here. This is KCL. What about KVL? So we are going to write KVL equations for the meshes. So that's the first mesh, that's the second mesh. For the first mesh, voltages in this mesh, all the elements voltages in this mesh, sum of them is going to give 0. So V10, what's going to be the sign? It's going to be plus, isn't it? Why it is plus? Because the mesh direction is the same as this element current direction, plus. What about 20 ohm resistor current is also in the same direction with mesh 1, so plus V20. Minus Vs is equal to 0. Why minus Vs? Because Vs independent voltage source current is downwards and mesh direction is upwards, so opposite to each other. That's why we put that minus in front of that Vs. The second mesh, so it's going to be minus V20. Why is that? The direction of this and the direction of this second mesh direction. So this is mesh 1, mesh 1, mesh 2. So we are writing now Kirchhoff voltage law equation for mesh 2 direction, and the 20 ohm resistor current is opposite direction, so it is minus. And mesh 2 direction and the inductor current direction is the same, so it is plus VL, and similarly plus VC is equal to 0. So we wrote these two equations now. These two equations are this KVL, and this 3 KCL is this one, isn't it? So what is left? The elements definition relation. So for the resistor is going to be in S domain, of course. V10 is equal R time, so 10 I1, V20, 20 I20, and VL, SL, which is the impedance of the inductor, so 0.1 SIL, and VC is the impedance of the capacitor, which is 10 to the power 4 over S, impedance of the capacitor multiplied with the current of capacitor. So 4 of them. The last one is the independent source voltage, Vs, definition relation. Vs is equal 10S, written here, which is the Laplace transform of this time domain function, isn't it? 10S over S square plus 10 to the power 4. So there are 5 equations here, 2 here, 3 here, total 10 equations, 10 unknowns. So the number of equations equal to the number of unknowns, and these equations are independent ones, means this inverse of this matrix exists. So that means you can find that A minus 1B. So that means you can calculate all the elements, current and voltages, a unique way. One of the conclusions that we can say just by looking at this mathematical model is this: all the elements, current and voltages depend on the B elements, B entities. B entities includes zeros and independent sources. So conclusion that all the elements, current and voltages depends on independent voltage and current values. So for this circuit, for example, all the elements, current and voltages depends on that Vs. So if you do this calculation, so you could do it at home. What is inside of this A matrix is, because of these equations, there's going to be, in this A matrix, for this equation, it's going to be plus, minus, ones and zeros, we are going to see. In here, we are going to see 10, 20, and the impedances of all these elements. We're going to see it in A matrix. So I wrote here I1 in S domain. This is the conclusion that we found when we analyzed the circuit by using serial parallel connections, and also we have done the analysis the same circuit by source transformation. We found that I1S value as this, as you see it, it is Vs multiplied a coefficient, isn't it? Comes from that. So if you do this calculation here, 10 unknowns, 10 unknowns, 10 equations, you're going to end up with that I1S value is this. That is the validation of the analysis that we have done already. That's the end of this video then. Let's stop here.